Hey guys, welcome back to our series of Cracking the Coding Interview, the #1 book recommended for software engineers for software interviews by the top companies in the world. Today we're going to be solving a problem called zero matrix. Okay, feel free to pause the video to read through this problem. This problem also happens to be a LeetCode problem right here, and we've actually started solving this problem in the past, right? So feel free to pause this and just to make sure it's the exact same problem. Like I was saying, we've started solving this problem in the past, and we started solving it using a kind of different way of solving it. We ignored this last constraint, okay, which also happens to be the same as the constraints given here in LeetCode. We ignored this last constraint and solved it by creating two new arrays. So this array is m by n, so technically we solved it using what I call linear space, O of m plus n, because we created two arrays. However, we ignored this last constraint, and today we don't want to ignore this. We want to take care of this. So can we solve it by using only constant extra space, meaning we're not allowed to create any data structure that can grow based on the size of this matrix like an array? We're only allowed to create a constant. And the answer is yes. Let's try to do it. Let's try to do it here. So here's how we're going to try to do it. Rather than create these two arrays we created in the past, can I technically use this row to kind of represent this array, and also use this column to kind of represent this array? Can I do it? And the answer is yes, I can. However, there's one challenge, and the challenge comes for this element right here, okay? This element a of 0, 0, because in the case of the arrays we have two different arrays, so this guy is different than this guy, but here they happen to be the exact same element. So to take care of this, because what happens is in the case where, let's pull up a case where for some reason there's a 0 here, based on this problem this is asking, right, it's gonna make us change this to a 0, which essentially is gonna make us change all of this row to zeros, right? Which obviously that's not right. That's not what we want to do. So we're going to create an additional variable, okay, which I'm going to call column 0, and we set him equal 1 at first, okay, and he's going to keep track of just this first column, right? He's going to keep track of this first column. Anytime if there's a 0 in this first column, anywhere in this first column, we're going to change him to a 0, otherwise he stays a 1, okay? So let's see what this algorithm is going to look like. Okay, so I'm going to go ahead and wipe off these two arrays, because obviously we're not going to create them in this solution. That's the whole point of choosing this solution, because it's more optimal than the previous one. So let's go ahead and wipe it. Okay, so first what we're going to do is we're going to write our for loop. So it's going to be something like this: for I going from 0 to the length of matrix. Okay, something like this. So what do I want to do now? I want to look through this first column, and if I see any 0 in this first column, I want to change this column variable I created to a 0, right? Because he keeps track of this guy for this column, right? Just so we can decouple the connection between these two guys. So it's simple. I'm just going to say something like if mat of I 0, not j, because we only want to loop through this first column, which is j equals 0. If this guy happens to be equal to 0, what do we do in this case? We just say this new variable we created from 0 equals 0. That's it. So let's see what it's going to look like. In our first iteration, I is going to be equal to 0. J is always 0, right? Because we hard coded it here to 0. So in this stage, in 0, 0, in this example, he's 1, right? So we do nothing. Nothing happens, right? Let's go to the next iteration. I equals 1. J is still equals 0 because we're only going through this first row. Guess what? That's also a 1. In this example, we do nothing. And for the third one is similar. I equals 2. J equals 0. Also happens to be a 1, 2, 0, so 1, absolutely nothing. So now we're done with this case. Let's move on to our next case. So our next case is, since we've iterated through this first row, we want to iterate through the rest of the row. And if we see any zeros, we want to change the corresponding row and column of the first guys to 0, just kind of like we did with the array. So these two guys are now representing the two arrays we just deleted. Again, watch the previous solution before this link in description for this to make a lot more sense to you. So this is going to look something like this: for I going from 0 to length of the matrix map. Okay, it's a nested for loop since we're going through the whole of the array. For j, again, we've gone through j equals 0 with this first case, right? We've gone through all this first, so we only have to start j from 1 this time to the length of the columns. So map of I, so this is all j goes to. Okay, so now we're going to ask ourselves the question: if map of I j happens to be 0, what do we do? Simple, we just set map of 0. Again, if we see a 0 in the rest of this, we want to set the corresponding rows and columns of these first guys to 0. That's the whole point of doing this. So 0 j is going to be equal to math of 0, not 0 this time, of I is I, and 0. They both reset them to 0. Okay, so let's see what this is going to look like. So first we're going to we're obviously going to start with I equals 0, j equal 1, right? I'm going to rule a line right here, okay, because obviously we're starting j from 1. In this case, obviously, it's this guy, 0, 1. This guy is the 1, nothing happens. We go on to the next guy, I equals 1, j equals 1. So at 1, 1, 1, I'm sorry, j is going to move, not I, so I is still going to be 0. I equals 0, j equals 2. So at 0, 2, that's a 1, nothing happens. Then we're going to go forward. I is now going to be 1, j is also going to be 1. So in this case, that's now this guy. Remember, we've done this first row already, so we don't have to do it again. So now we're on this guy. This is a 0, right? So we're going to do stuff. We're going to do something. And what are we going to do? Something, what this for loop says. It says if it happens to be 0, we're going to replace each of the guys to 0. So in this case, since we have a 0 right here, we're going to replace this row and this column, because that's the whole point of using those. So this is going to change to 0 and this is going to change to 0. Okay, then we know what the rest of this, everyone else in this matrix. So let me just write the next case. I equals 1, j equals 2. That's a 1, so we do absolutely nothing. And I'm not going to bother writing the remaining two cases, which is these two, because we know it's 1 and we do nothing, right? This in this example at least. So then we're done with this. We're fully edited this guy. But however, I want to show you guys something. This first for loop we have in the first case right here, it happens to be the same as this for loop. You see, for I from 0 to length math, for I from 0 to length math. So rather than have two separate for loops, what we can do is to simplify this. We can just copy this code right here and place him right here, right? So that kind of negates the need for this side separately, because now we've combined it in here. Okay, so now lastly, we're going to have to go through our matrix to see where this column and this row is zeros, and whatever index, if either of this is 0, so say we're on this guy, if either this or this is 0, he becomes 0. So we're on this guy, if either this or this is 0, he becomes 0. So we're going to have to do it for this matrix, but we're going to do it from the end this time, starting from the last guy. So the code is going to look something like this. It's going to be for I, obviously going from 0 to length math. But again, we want to do it in reversed. So I'm going to put a REV in front of it, reversed. We're going to start from the back. Okay, also we're going to have a for j, again going from 1 to length of the column mat of I. Again, reversed. That's why we have an REV in front. We're going to do it in reverse. Okay, so if in this two for loop, if say for instance, if mat, we want to check these two columns, right? If mat of row 0 and j happens to be 0, happens to be equal to 0, or mat of I 0 happens to be equal to 0, if either of this is 0, we're just going to say mat of I j equal to 0. We're just going to set them to 0, right? So we're just going through this matrix, kind of like we did here, but in reverse order. I'm just setting based on these columns to 0. And then lastly, we want to also do something like this here. We want to say, we want to look if to change this first column. Remember, because this doesn't touch the first column, right? If there happens to be a 0 here, which remember that's the whole point of creating this column 0 variable, right? If he happens to be a 0, then we want to change all the elements to 0. So pretty much we can do this by adding this to the last section, saying if, again, still inside this first for loop, but outside of this j for loop, if this column 0 happens to be equal to 0, all I want to do simply is just say mat. Remember, we're going through the first column, so that's I, row I, column 0 is just going to be 0 every element. So if this column happens to be 0, every element in the first column happens to be 0, and that's it. We are done. So let's go ahead and see what the code is going to look like. Okay, code is going to be actually pretty straightforward. So the code is going to look like something like this. Okay, here's the column 0 guy setting to 1 at first. Here's the for loop. Okay, here's me checking only the first column of the matrix to see if there's any 0 there. If there's a 0, I change this column guy to a 0. Then here's me checking the rest of the matrix except for the first column, right? So starting from 1. And if any of the elements happen to be 0, I change the corresponding elements in the first row and the top row and first column to 0. Then here's me going through again in reversed order through the matrix, okay, and saying, hey, if any of the first column, okay, or the top row, if any of the corresponding element happens to be 0, that corresponding index ij of the matrix is also 0. And here's me lastly checking the first column by itself, since I didn't check it in here because j starts from 1, saying, hey, if column 0 happens to be 0, then every element, okay, in this first column also happens to be 0. So let's go ahead and run this for the example. Bam. Okay, let's run it for matrix 1 actually. We know what to expect for matrix 1. I think I just called it matrix. So bam, is correct. Also, I took the liberty of going into LeetCode and copying and pasting the solution. This is the exact same solution, copy and pasted here. However, it says we don't have to return anything. So I omitted the return statement for LeetCode because LeetCode keeps track of the matrix by itself. And also in my example, I call it math. LeetCode calls it full word matrix. So that's why I use matrix, but everything else is the same. So let's go ahead and run this. Bam, bam, accepted. Faster. So in terms of speed, faster than 91 percentile of Python, or almost 100 percentile in terms of space complexity. So that's it for the video, guys. I hope it was helpful, and I'll see you in the next one.